Hi folks, and welcome back to Math with Captain Rod. The purpose of this video is to demonstrate how to differentiate inverse trig functions. So the answer to how to differentiate inverse trig functions is implicitly. So the one we're looking at right here, we're going to go through this example, y equals inverse cosine of 1 over x. And what we're going to try to calculate is y prime, the derivative of this function. Now, remember what the inverse cosine function is. Y is the value that is going to satisfy the equation cosine y equals 1 over x. And you can get that just by taking the cosine of both sides of this thing. So if I think of the cosine function as an operator, you'd have cosine y on the left, then you'd have cosine of inverse cosine of 1 over x. That would give you 1 over x on the right. Now when we differentiate this, differentiation of the left-hand side is going to read minus sine y dy dx. This is coming from this. The derivative of the cosine function is minus sine, but y is a function of x, so this needs to be chain ruled. So the derivative of cosine y would be minus sine y dy dx, right? And that's from the chain rule, equals, differentiating the right-hand side. And there's a couple ways to differentiate this. You could think of this as x to the minus 1 and you apply the power rule, or you can apply the quotient rule. Either case, you get minus 1 over x squared for the derivative of the right-hand side. Again, you can think of this as x to the minus 1. Bring down the power. There's your minus sign. Subtract 1 from the power. That would become a minus 2. Now what we'll do is just solve this for dy dx. So dy dx is going to equal 1 over x squared, and you'll notice we're going to have to divide by sine y. The minus signs cancel. Now we've got this almost done, but you notice we're going to have to figure out what are we going to do about this sine y part right here. Well, we can use this to draw a nice little triangle. In this equation, y is some angle, and the cosine of y is equal to 1 over x. Remember that cosine is adjacent over hypotenuse. So in this triangle, this would be a 1, this would be an x. And now what we have to find is this side here. I'm just going to give this a name for just a moment and call it h. We can find that side by Pythagorean theorem, because 1 squared plus h squared has to equal x squared, because this is a right triangle. So h squared is going to equal x squared minus 1. So h is equal to the square root of x squared minus 1. So we can use this triangle now to find an expression for sine y. So this is going to equal 1 over x squared times sine y. And I'm looking at my triangle here, sine y. And remember that sine is opposite over hypotenuse. So that's going to equal this, square root x squared minus 1 over x. And you know, remember the old saying about dividing by a fraction, that's the same as multiplying by its reciprocal. So basically these x's cancel. So this gives us 1 over x root x squared minus 1. And this is done. There's dy dx for this function. I think what I'll do here is I'm going to just pause this and then write out another example. Alright, got my second example written up here. So we're looking at the function y equals inverse tangent of ln of x, and what we're going to do here is try to differentiate that with respect to x. So we're looking for dy dx. First thing to realize here, if we take the tangent of both sides, this is going to read tangent of y equals ln x. Okay. Now when we differentiate, keep it in mind the derivative of tangent is secant squared, so the left-hand side is going to read secant squared y dy dx equals, and then differentiation of the tangent function, the derivative of ln x is 1 over x. So the differentiation part is now done. All right, all we have to do is algebraically solve this for dy dx. But before we do, we got to figure out how we're going to deal with this secant squared y. And the way we do that is we look at the equation before it, and we're going to use it to draw a triangle. Now this reads tangent y, y is some angle, equals ln x. Now remember that the tangent function is equal to opposite over adjacent. I'm going to write this ln x over 1. Opposite over adjacent. So in my triangle, here's the side opposite y, so that's going to equal ln x. Here's the side adjacent to y, that's a 1. And then by Pythagorean theorem, the hypotenuse of this triangle is equal to the square root of 1 plus ln x squared. Now, secant is 1 over cosine, so I'm going to go ahead and write this 1 over cosine squared y dy dx equals 1 over x. Then to solve for dy dx, we just have to multiply by cosine squared y. And I'm going to look over to my triangle here to get that cosine squared y. So looking at my triangle and keeping in mind that cosine is adjacent over hypotenuse. So cosine y is equal to 1 over square root 1 plus ln squared x. So cosine squared is therefore equal to 1 over 1 plus ln squared x. I can write that ln a little better. Natural log squared x. So if we square this, the 1 squared is 1, and the bottom squared is 1 plus ln squared x. And then we still have this times 1 over x. Go ahead and put that in parentheses. And I'm going to call that done. That function is differentiated, and there's its derivative. So I think I will just stop this video right there and start another one for these examples. Hope this video helps demonstrate how to differentiate inverse trig functions. Have a great day.